FTIR measures the infrared region of the electromagnetic radiation spectrum. What is being measured has a longer wavelength and a lower frequency than the visible light. It only becomes measurable when it is exposed to infrared radiation, making this device necessary to get these readings. Now the instrument looks like this, seen in this slide. It has a build that includes a light source, a sample, 2 mirrors, a laser reference, detector, and a beam splitter. All these together make up the device that's seen on this slide and get the readings for the FTIR.
For each IR experiment, an infrared electromagnetic wave is first generated and beamed towards the sample. Typically, a sample would be composed of different types of molecules, and each molecule has its own unique resonant frequency or vibration. Now, because of these resonant frequencies, the infrared will either be scattered or absorbed, resulting in the waveform being constructed or deconstructed, as there are multiple resonant frequencies at play affecting the outlook of the time amplitude signal or time absorbance signal. This signal can be transformed, so instead of having the time domain, we can look at the frequency domain. In the case of light or infrared, we are concerned with the wavelength, and as you may know, the inverse of frequency is wavelength. And with that, we can absorb peaks on this wavelength absorbance curve. So this will help us view the abundance or presence of a certain molecule that absorbs light at a specific wavelength. So to better understand the type of information we get from this technique, let's pretend that we have a sample that's composed of nuts, an analogy for molecules. Now, assuming that we have a library of the absorbance wavelengths that correspond to nuts, we can extrapolate the general molecular composure or nut composure of our mixture.
FTIR spectroscopy is not only convenient but also accurate when identifying unknown materials in either gas, liquid, or solid states. Materials can range from both organic or inorganic compounds, powders, polymers, liquids, and gases. Another convenience is that analysis of samples can be done in their natural states. This meaning minimal sample preparation is also needed. FTIR spectroscopy could be seen as an all-in-one technique for quantitative measurement. It is quick and easy to use and overall very precise when identifying materials, which leads to it being cost-efficient due to not only its multi-purpose use, but also the data given helps scientists and specialists determine their next steps after their findings.